Hi students and parents, my name is Mrs. Cooper. I'm a third grade teacher here at Washington School, and I'm going to be talking to you a little bit about how to round and estimate today. This is a skill that we are currently working on in Chapter 2 of Mathematics. So, let's talk a little bit about rounding. Rounding is a skill that the students need in order to estimate. For example, in our class we're talking about estimating sums and estimating differences. And eventually we'll talk about how to apply those to word problems. But step one is figuring out how to round. Not only how to round, but really also truly understanding what that means to round. So let's start off by taking a very basic number. A number, let's say, like 42. And I want to round this number to the nearest 10. Well, there are a couple strategies that I've taught my students. However, we need to start off very basic. And the first thing we need to do is teach the students to understand where this number would fall on a number line. So if I asked my students today, what two tens 42 would fall in between, 42 would fall in between the tens 40 and 50. So here's what our number line would look like. We'd have 40 and 50. If I had the students plot the number 42 somewhere on the number line, it would go right about here. Now we can actually see that 42 is much closer to 40 than it is to 50. So what we would say is that 42 would round down to 40. Now this is a great visual for the students because, again, when we think about rounding, we visualize it this way. They need to understand how rounding applies to number sense. Now, what I have been teaching to the students in class is how to be much more fluent in rounding, because that's a big focus in third grade. The students should be able to round to the nearest 10, 100, or even 1,000, either using a quick strategy or by rounding off the top of their head mentally. So, now that we've rounded 42 using a number line, let's try it using a strategy that I like to call the house strategy. This strategy is going to help our students become a bit more fluent in rounding. And this is going to be extremely important when it comes to estimation. So, let's again take the number 42. Now, if we wanted to round this number to the nearest 10, like the directions say, what we're going to do is put a house around the digit in the tens place. Okay, I call this the house strategy. There's my house. Now what we need to do is look at his neighbor, the digit 2. Now something we have to keep in mind is, for example, what is that digit 2 going to tell us to do as far as rounding goes? Something that I explained to my class is something called strong arms or weaklings. So for example, the digits 0 through 4 we consider to be weaklings, and the digits 5 through 9 we consider to be strong arms. The reason I use that analogy is because the strong arms, 5 through 9, can actually push up their neighbor, and therefore this number would round up. The weaklings are too weak to do that, so they cannot be pushed up, they cannot be rounded up. Instead, they round down, they remain where they are. So for example, let's take a look. The digit 2 is a weakling. He is not strong enough to lift the 4 up to a 5, so the 4, he remains the same. And something else I like to say is that all of the digits or neighbors that fall after the house, in this case we have the digit 2, he turns into a 0. So just as we had said before, 42, using the number line, rounds down to 40. And again, using the house strategy, 42 rounded to the nearest 10 is 40. Again, if you ask your children at home to list for you all of the tens, they should be able to do it quite fluently. For example, 10, 20, 30, 40, 50, 60, and so on. Okay? Same with our hundreds, 100, 200, 300, and our thousands, 1,000, 2,000, 3,000, 4,000. So essentially, they're skip counting by tens, by hundreds, and by thousands. But they need to know those numbers in order to decide where they're going to round. So let's try another quick example using a 3-digit number. So let's say, for example, we had something like the number 561. and I wanted to round this number now to the nearest 100. Again, like the directions tell us, we are going to put a house around the digit in the hundreds place because we are rounding to the nearest 100. So place value is also extremely important here, especially when rounding. So students definitely need to know their places, their ones, tens, hundreds, thousands place, and the difference between them in order to successfully complete this strategy. So again, I'm putting my house around the digit in the hundreds place. Okay, now what we're going to do is look at his closest neighbor, and in this case, that is the digit 6. Now looking at our strong arms and weaklings, the digit 6 would be a strong arm. So in this case, the digit 6, his neighbor, is in fact strong enough to push the 5 up to a 6, and here's what happens. So I'm just going to erase this so I can show you right underneath. 6 is a strong arm, 5 does get pushed up to a 6, and like we said before, all of the digits that fall after the house, in this case, it's the digits 6 and 1, they both turn into zeros. So we say that 561 would round up to 600. Again, if we were to draw a number line, and I were to ask my students, what two hundreds would 561 fall in between? Sometimes I even kind of hop back and forth and say, which 100 would fall here, what would fall here? Now, they should be able to say, using their number sense, that 500 and 600 are the 200s that 561 would fall in between. And if I was going to plot this on my number line, this would be 550. 561 might go somewhere here. Now, visually, they can see now that 561 is much closer to 600 on a number line. So, if we were going to, again, round 561 to the nearest 100, it would be 600. So the number line is something that we're sort of straying away from here in 3rd grade. This is definitely the strategy that we use to begin and introduce the skill of rounding, because it is important not only to know how to round, but to understand what is happening when we round. So the number line does play an important role. However, now that we have become much more fluent, we are straying away from that and using strategies like the house strategy here. Now, what I've noticed in class is that after using the house strategy for a few weeks, the students have actually become quite fluent in rounding, and they don't necessarily have to use the strategy much anymore. Many of them can do it right off the top of their heads. So for example, just today I said to the students, what would 561 rounded to the nearest 100 be? And many were able to look right at that number and say within less than a minute that 561 would round to 600. Now that will come over time. If you notice your child is struggling at home to understand the concept of rounding, please feel free to continue drawing out number lines. You can also print them off of the internet. Also, I've really had to encourage my students here to do the work. A lot of them would like to do these strategies mentally in their head because many of them around them can already do so. However, not everybody is there yet. So I've had to encourage my students to actually draw out the house, write their arrow, and by doing so, they can then visually see and understand what is happening when they round. So once they get used to using these strategies, the fluency will come in time. So now that we know how to round, let's talk a little bit about estimation. Now, we did say that estimation is an educated guess, but in order to estimate, the students need to know how to round, which is why we start with this strategy first. So assuming that the students now know how to round, and many of mine do, we're going to move on to estimation. Now, we are going to talk a little bit today about how to estimate sums. We've also talked about how to estimate differences as well, but the steps to do so are exactly the same. The only difference is that estimating sums, we are adding, and estimating differences, we are subtracting. In my class, I come up with little jingles here and there to help the students remember the difference between these math vocabulary words. It's extremely important to know the difference between sum and difference because it does tell the students which math operation they're going to need to use. So for example, I say that the sum is the answer that you get when you add, okay? And the difference is the answer that you get when you subtract. So we're just going to estimate sums today. However, estimating differences, the steps as far as rounding goes are exactly the same. The only difference is that you will be subtracting to get your answer instead of adding. So let's talk about estimating sums. Let's write a very basic problem on the board to start. Let's do something like 26 plus, how about 32? Now, when we are estimating sums or differences, we are not looking for an exact answer. That is probably the first and last time that we will ever say that in class, and I've always joked with my students about that same thing, right? The first time we're not looking for an exact answer. We want an estimated answer, and in order to estimate, we need to round. So, I always tell my students that the first step before you add or subtract is to round your numbers, and then you can go ahead with your next math operation. So let's take a look at the number 26, okay? We are going to round both of these numbers to the nearest 10. I might ask my students, what is 26 rounded to the nearest 10? Again, many of them now can do that very mentally. Some may have to sit down and actually draw out their houses, look at the neighbors, decide, 6 strong arm or weakling, and then go ahead and round it that way too. And that's okay. Please encourage your child to do that at home if you notice that they are struggling. So I'm going to do this mentally off the top of my head just to save time. So we know that 26 would round up to 30 because 6 is a strong arm. And if we drew out a number line, 26 would be much closer to 30 than it is to 20. Okay, in the next step, let's round 32 to the nearest 10. That we know would also round to 30 because 2 is a weakling, 3 remains the same, digit turns into a 0. Now what I like to say is that we have a math problem that has become pretty much mental math. We can look at 30 plus 30 and do this addition right off the top of our heads. So what we've noticed in class was that the addition here, it's not difficult per se, but it becomes a lot less challenging and a lot more mental when we round first. Okay, so after we've rounded, we have 30 plus 30, and most students can easily and quickly say that the sum of 30 plus 30 is going to be 60. Okay, so 60 would be our estimated sum. Now we're not done yet, because what we need to do is now find the actual answer to make sure that our estimate is what we call reasonable. If our estimate is way off in left field, then clearly we have done something wrong. And it's so important that we go back and we look and reflect and see where we made our mistakes. Was it in our addition computation or rounding? So let's take a look and let's make sure that we've rounded, in fact, correctly. So let's take 26 and 32 and add them together. So here we go. I like to write them vertically. That especially helps when there's regrouping. Okay, so 32 plus 26, 6 plus 2 is 8, and 3 plus 2 is 5. So our actual answer, we'll fill that in. 26 plus 32 is 58, and our estimate is 60. And what we would say is that 60 is certainly a reasonable estimate because, first of all, 58 would actually round up to 60, and if we drew out a number line, we are only 2 away from the actual answer. So, 60 again is a reasonable estimate. Let's try another one using a 3-digit number. So let's try something like, let's see, how about 562 plus 123. Okay, again, we are not looking for an exact answer here. We are looking for an estimate. So when we are estimating sums or estimating differences, the very first step is to round. And again, you can go back to either the house strategy or you can go ahead and draw a number line to help you. So let's try 562 rounded to the nearest 100. So again, right, nearest 100, there's my house. Let's take a look at his neighbor, the 6. We said 6 was a strong arm. He will push the 5 up to a 6. And my digits that fall after the house, those two neighbors, they turn into zeros, okay? Now 123, same idea, okay? Round to the nearest hundred. 2 is a weakling, 1 remains the same. The digits after the house turn into zeros. And now my addition problem has become mental again. So 600 plus 100, many third graders should be able to do this right in their head, and they should be able to say that 600 plus 100 is 700. Now this is our estimated sum, but we have to double check and make sure that it is reasonable. So what we're going to do is now actually add 562 and 123 together to see just how close we were to the actual answer. So let's write it vertically again, in case we have some regrouping. Okay, so here we go. 3 plus 2 is 5, 6 plus 2 is 8, and 5 plus 1 is 6. So no regrouping here, but what we notice is that our answer, our actual answer, we'll erase the question mark now that we know that, is 685. If we look at our estimated answer, we got 700. Now we can definitely say that 700 is a reasonable estimate. And we know that because 685, if we draw out a number line, is not too far from 700. Secondly, 685 would also round up to 700. If, for example, the students got something here, they got an estimated sum that was way in left field, like 900, then they would have to go back and say to themselves, what did I do wrong? Because that is certainly not reasonable. That's not a reasonable estimate for 685. So what they may want to do is go back and double check, make sure they rounded correctly, and also make sure they added correctly. So there may be a mistake in either computation, okay, or in rounding. Okay, so if you find a mistake, there may be an error in one of those two things. All right, now what we'll do is I did say that we would go back and round to the nearest 10 just to see what answer we would get here. So we'll keep this number, 685, because that is, of course, the actual answer. And let's go ahead and round these two numbers to the nearest 10. We'll just erase this. So we had 562 and 123. All right, let's round these two numbers to the nearest 10 using our house strategy. So again, to the nearest 10, that's where the house would go. We look at his neighbor, okay? The neighbor is a 2, which means he's a weakling. 6 would remain the same. The digit that comes after the house turns into a 0. And I like to call the digits that come in front of the house, or these neighbors that come in front of the house, I like to refer to them as our lazy digits or our lazy neighbors, because they simply just come right on down. They don't change at all. They just come along for the ride. So 562 would round to 560 if we're rounding to the nearest 10. And let's try it with 123. So same idea, house around the digit in the tens place. We look at his neighbor, and that is a 3, also a weakling. So the digit 2 would remain the same. 3 that comes after the house turns into a 0, and my lazy neighbor or my lazy digit will come down and come along for the ride, so he does not change. So now we have 560 plus 120. What I did tell my students in class was that even though rounding to the nearest 10 is going to get us really close, even closer to the actual answer, they took a look at the addition problem and realized that they had a little bit more work to do. So it became a little bit less mental. So I told them that they could round to the nearest 10 or the nearest 100. However, sometimes the problem may direct the students to do it a certain way. So the word problem or the addition or subtraction problem may specifically say round to the nearest 100. Or round to the nearest 10. If it doesn't, then they have the option of doing either or. So this is the reason I'm teaching this as well. So now that we've rounded to the nearest 10, let's take a look, okay? I'm going to rewrite this vertically and see what we get. Okay, so 560 plus 120 is 680. Now remember, the last estimated sum that we got was 700. So look how much closer we got to the actual answer by rounding to the nearest 10. Okay, we were only about 5 away here. Okay, so again, I tell my students in class, if the directions don't specifically say to round to the nearest 10 or 100 or 1,000, then you can go ahead and round any which way you'd like. You just have to make sure that A, you are rounding correctly, and B, that you are adding or subtracting correctly. Now, we are also talking about estimating differences. The steps would be exactly the same as the ones that I've explained here, except for the fact that our math operation would change from addition to subtraction. So again, if this was a subtraction problem, we would round our numbers first, subtract them to get an estimated difference, subtract the actual numbers to get the actual difference, and compare and think, is my estimate reasonable? So that was a quick little mini lesson on how to round and estimate sums and differences.